All right, welcome to 5.4. Our goal here is to define some key terms related to matrices, including identity matrix, zero matrix, matrix inverse, and determinant. I will say this, matrix inverse or an inverse matrix, we're going to deal with that in 5.5, so I'm not going to define it here. All right, so let's go ahead and get this party started. The first thing we want to take a look at is the identity matrix. All right, so the identity matrix. This is probably one of the most important ones, right? Your identity is who you are. So as far as identity matrices, this one is going to be crucially important, okay? So I'm going to say it first, and then I'm going to give an example of this, okay? An identity matrix is a square matrix in which the main diagonal has ones for each element, and the remaining elements are all zeros. Whoa, okay. What are you saying here? So first of all, it has to be a square matrix. Second of all, the main diagonal has ones, and then all of the rest of them are zeros. Okay, let's go through a couple of examples here. Let's take a look at a 2 by 2. All right, a 2 by 2 identity matrix looks like this. All right, so our main diagonal goes top left, bottom right. That's the main diagonal. That has ones, and there's zeros everywhere else. Let's take a look at a 3 by 3. Note, these are square matrices, right? They're square matrices. So a 3 by 3 would be a 1, 0, 0, a 0, 1, 0, 0, 0, 1. Okay. Okay, girl, I see. So there's going to be a diagonal, right, where the ones are going to go from the top left to the bottom right, and those are all ones. Everywhere else is going to be zeros. All right, so 4 by 4 is going to be a 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That's a 4 by 4. Oh. What about an n by n? How would you do that? How're you going to do that? You're going to do 1, 0, 0, dot, 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 dot. 0, 1, 0, dot, 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 dot. 0, 0, 1, dot, 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 dot. Dot, 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 dot. All the way down to n. All right, so as long as there's a 1 in the main diagonal and zeros everywhere else, and it's a square, then it would be the identity matrix. We refer to this as the ID, the identity matrix. Sometimes you'll see people write it as just an I. Okay. Here's what's awesome about the identity matrix. What's super cool about the identity matrix is that when you multiply a matrix by the identity matrix, you get the original matrix. What? Let's try this out. So, what I'm saying is, any matrix times the identity matrix will become the original matrix. So let's find a random 2 by 2. So let's go 3, negative 4, 7, and 11. All right, there's A.
If you're on second hour plan and you're willing to help me out, please give me a call at 7114. Again, anybody on second hour plan willing to help me out, please give me a call at 7114. Thank you.
We multiply that with the identity matrix, 1, 0, 0, 1. All right, so I have a 2 by 2 times a 2 by 2. All right, the result's going to be a 2 by 2. All right, so row the first, column of the second. So 3 times 1 is 3. Negative 4 times 0 is 0. Row the first, column of the second. So row the first column of the second. 3 times 0 is 0. Negative 4 times 1 is negative 4. Second row, first column. Second row, first column. 7 times 1 is 7. 11 times 0 is 0. Second row, second column. 7 times 0 is 0. 11 times 1 is 11. What's the result? 3 plus 0 is 3. 0 minus 4 is negative 4. 7 plus 0 is 7. And 0 plus 11 is 11. So any matrix, any square matrix times the identity matrix will result in the original matrix. Huh. What's that like? Whenever you ever multiplied a number, like any number, times there's one specific number, and you always get the original number back. What number is this? All right, that's always going to be 1. All right, for example, 5 times 1 is 5. That's interesting. That, to me, is really, really fascinating. So some properties from arithmetic hold true when it comes to matrices. Other properties do not. All right. Now let's take a look at one called the zero matrix. So the next one is the zero matrix. This is a square matrix.
Can I get a custodian to room 308 to unlock the door, please? A custodian to room 308 to unlock the door. Thank you.
Where every element in the matrix is a 0. Well, this is boring. All right, so 2 by 2. 0, 0, 0, 0. 3 by 3. 0, 0, 0, 0, 0, 0, 0, 0, 0. Boring. But what's neat about this, right, is that whenever I multiply, or not multiply, because then that's boring. Whenever I add a matrix with this matrix, I should get the original, right? So if I did, 5, negative 2, 6, and 1, and I add that with the zero matrix, the result is the original matrix. And that's a whole lot like in math whenever we do something like 7 plus 0 is 7. Whenever we deal with that in arithmetic. That always fascinates me. Some of these patterns are really, really fascinating. All right. On the part B, we're going to talk about determinants. Determinants are going to help us determine some things later on down the road. We'll see you in the next video.